Welcome to Formcule tutorial. Today, I want to show you how to prove simple linear regression model. That is, how to obtain alpha naught and beta 1. The question can come in this form, that is, given x1, y1, close the bracket, comma, dot, comma, into the bracket, s subscript n, comma, y subscript n, close the bracket. The line of best fit is y equal to alpha naught plus beta 1 s subscript I. Now say that so that alpha naught equal to summation of I ranges from 1 to n y subscript I minus beta 1 of I ranging from 1 to n s subscript I divided by n, and beta 1 equal to summation of I ranging from 1 to n s subscript I y subscript I minus into the bracket summation of I ranging from 1 to n s subscript I and summation of I ranging from 1 to n y subscript I divided by summation of I ranging from 1 to n s square subscript I minus into the bracket summation of I ranging from 1 to n s subscript I close the bracket square. The line of best fit simply means y equal to alpha naught plus beta 1 s subscript I. The reason why we want to show we have alpha naught and beta 1 is to obtain the minimum value of the sum of square error. Now, we now say that let s subscript r be the sum of square error. Then, what is error in statistics? Error simply means observed minus predicted value. Statistically, error equal to y minus into the bracket alpha naught plus beta 1 s subscript I. Take the summation of both sides. So therefore, we have already taken the summation of both sides. That's at the top there. And after we take the summation, the next step is to take the square of both sides. That is, square both sides. That is exactly what we have now. And after that, the next step we need to take is that take the first derivative of the equation above with respect to alpha naught. That is, we are going to differentiate the equation 1 with respect to alpha naught. We want to estimate alpha naught first. And this is the first derivative of alpha naught. So after we took the first derivative of the equation 1, we obtain this equation. And the next step is that set the left hand side to 0. The reason why we set it to 0 is because there is no alpha naught that we are taking the derivative with respect to in that side. That's the reason why we set it to 0. So, and after that, we have this equation. We have this the right hand side equation. Remember the right hand side equation. The next step here is that multiply 2 and negative 2. We multiply it together and we have this equation, which is negative 2. Summation of I ranges from 1 to n into the bracket y minus into the bracket alpha naught plus beta 1 s subscript I close the bracket equal to 0. The next step is to divide both sides by negative 2. And when we divide both sides by negative 2, we divide both sides by negative 2 in this equation, and we have this equation. We have this equation. And if you look at it very well, we say that summation of I ranges from 1 to n into bracket y minus into the bracket alpha naught plus beta 1 s subscript I close the bracket, which equal to we use the negative sign to open the bracket of that alpha naught, and we have summation of I ranging from 1 to n into bracket y minus alpha naught minus beta 1 s of I close the bracket equal to 0. Now I want to use summation to open the bracket. And when we use the summation to open the bracket, we have this equation too. We have summation of I ranging from 1 to n y minus summation of I ranging from 1 to n alpha naught minus summation of I ranging from 1 to n beta 1 s of I, everything equal to 0. Note that anytime we are summing a constant together, that summation will return to n according to the rule of summation in statistics. That's the reason why we have n alpha naught. And based on that of summation of I ranging from 1 to n beta 1 x subscript I, we knew that beta naught is constant. That's the reason why we put it at the back of summation, and our x subscript I is a variable. Then that's the reason why we have. Hence, equation 2 now turn to summation of I ranging from 1 to n y minus n alpha naught plus minus beta summation of I ranging from 1 to n s of I equal to 0. The next step here is make n alpha naught the subject of the formula. And when we make it the subject of formula, we have negative n alpha naught equal to negative I ranging from 1, negative summation of I ranging from 1 to n y minus beta 1 summation of I ranging from 1 to n x subscript I multiply through by negative. When we multiply everything, we have this equation. Is n alpha naught equal to summation of I ranging from 1 to n y minus plus beta 1 summation of I ranging from 1 to n x subscript I. Divide both sides by n. When we divide both sides by n, we have this final equation, which is once alpha, we have this equation alpha naught equal to summation of I ranging from 1 to n y plus beta 1 summation of I ranging from 1 to n x subscript I, hence, and which is the value of our alpha naught. Hence, I will stop here for now and continue in my next video. Please subscribe to my channel for details about provings. Thanks. See you the next time.